Part we will study the trigonometry, the rest of the trigonometry. The first lesson is the circular sector. The area of circular sector equals 1 over 2 r power 2 theta rad, where L equals theta rad times r, where theta is the angle of the sector. This part is called theta. This angle is called theta. R is the radius of the circle. R is the radius of the circle. And L is the length of arc. L is the length of arc. What is the circular sector? The circular sector is a part of the circle like the slice of a pizza, like this part, like this colored part. This part is called circular sector. The required is to find the area of this colored part, this shaded part. So the area of this circular sector equals half r power 2 theta rad, half r power 2 theta rad. And we studied before that L equals L, which is the length of arc, equals theta rad times r. Let's have example for the circular sector. Find the area of the circular sector in which the length of the radius of its circle is 10 centimeters. So 10 centimeters is the radius, the length of the radius of the circle. And the measure of its angle is 1.2 rad. So the solution is area of the circular sector equals 1 over 2 r power 2 theta rad. 1 over 2 r power 2 theta rad. We will substitute. So 1 over 2 times r is 10 centimeters as given in the example. So we will substitute r and put instead of it 10 power 2 times theta rad was 1.2. So the answer is 60 centimeter squared. The second lesson is called the circular segment. The second lesson is called the circular segment. What is the circular segment? Is a part of the circle, surface of the circle bounded by an arc and a chord passing through the ends of this arc. Again, is a part of the surface of the circle bounded by an arc and a chord passing through the ends of this arc. For example, circle M and AB is a chord in the circle as we see. This pink part, this pink or red part is called minor segment, and this yellow part is called major segment. So the circular segment is bounded a part of the surface of the circle as we see the yellow part or the red part bounded by what? An arc and a chord passing through the ends of this arc. Again, where is the chord? The chord is AB. Where is the arc? ACB is an arc and ADB is another arc. So in this circle we have two circular segments. The small one, which is called minor segment, and the large one, which is called major segment. So the circular segment is a part of the surface of the circle bounded by an arc, as we see, an arc and a chord passing by the ends of this arc. Okay, so we have two segments. The minor segment is called ACB, ACB, and the major segment is called ADB. ADB. The minor segment is the red part or the pink part, and the major segment is the yellow part. The area of this circular segment equals 1 over 2 r power 2, 1 over 2 r power 2, theta rad minus sine theta. Again, 1 over 2 r power 2. R is the radius of the circle. As we see, the radius of the circle. This is r. Theta rad. Theta rad is the central angle. Is the central angle subtended to the arc. Subtended to the arc. Okay. And minus sine theta. So theta rad, theta in the radian form, minus sine theta in degree form. So we will find theta in radian form and in degree form to be able to find the area of the circular segment. So area of circular segment equals 1 over 2 r power 2 theta rad minus sine theta. Example. Find the area of the circular segment whose length of the radius of its circle equals 8 cm and the measure of its angle equals 150. The required is to find the area of the circular segment given its radius length and the measure of the central angle. The solution: theta rad equals, we will first convert the angle in degree form into radian form. So theta rad equals 150, which is the angle in degree, times pi over 180, approximately equals 5 pi over 6. So we convert the degree form into radian form. Sine theta equals sine 150. The given angle is 150. So the area of circular segment equals half r power 2 theta rad minus sine theta. Again, area of circular sector equals half r power 2 theta rad minus sine theta. So by substituting the values, so if the area will be equal 1 over 2 times r was 8. So 8 power 2 is 64. Bracket theta rad 5 pi over 6 minus sine theta, which is 150. So the answer is approximately 67.7758 centimeters square. The areas. Now we will study some areas. 3 types, 3 cases. The first case is the area of triangle equals half times AB times BC times sine angle ABC. As we see in the figure, AB, BC, so we need angle B. So the rule is A half times AB times BC times the sine of the included angle between the two sides. What is the included angle between these two sides? The included angle is B. The included angle is what? Is B. So sine angle B. For example, find the area of the triangle ABC in which AB equals 9 cm, AC equals 12 centimeters, measure angle A equals 48 degrees, approximating the result to the nearest hundredth. The solution. The area of triangle equals half times AB times AC times sine angle A, because the included angle is A. So by substituting, half times 9, which is AB, times 12, which is AC, times sine angle A, which is 48. So the approximated value is 40.13 centimeters square. Second, the area of convex quadrilateral. The second area is the area of the convex quadrilateral. The area equals half times the product of the length of its diagonals times sine the included angle between them. Again, area of convex quadrilateral. Quadrilateral is the figure formed of four sides. So its area equals 1/2 times the product of the lengths of its diagonals times the sine of the included angle between them. For example, find the area of the quadrilateral in which the lengths of its diagonals are 12 centimeters and 16 centimeters, and the measure of its included angle between them is 68 degrees, approximating the result to the nearest square centimeter. So the given is the length of the first diagonal and the length of the second diagonal and the measure of the included angle between them. The solution. The first diagonal here means AC, the second diagonal is BD. The included angle is theta, the angle included between the two diagonals. The rule is that the area of the quadrilateral equals 1/2 times AC times BD, the first diagonal, and the second diagonal, times sine theta, which is the angle included between them. By substituting, equals 1/2 times 12 times 16 times sine 68. So the angle approximately equals 89 centimeters square. The last area is the area of a regular polygon. The area of a regular polygon equals 1/4 n x power 2 times cotangent pi over n. Again, 1/4 n x power 2 times cotangent pi over n. Area of what? Area of regular polygon. What is the regular polygon? Polygon is the figure formed of straight of line segments. Any figure is the polygon is a union of line segments. Any number of line segments. Regular any number of line segments starting from three sides. Regular means that all lengths of the polygon equal and the measure of the angle equal. So the area of regular polygon means the polygon which its sides are equal in length and its angles are equal in measure. Where n the number of sides, n is the number of sides, and x is the length of the sides. X is the length of the sides. For example, find the area of a regular octagon. Area of what? Irregular what? Octagon. In which the length of its side equals 6 centimeter, approximating the result to the nearest hundredth. Octagon is the polygon formed of 8 sides. So the solution is area of regular polygon equals 1/4 n x power 2 times cotangent pi over n. By substitution, equals 1/4 n number of sides, which is 8, times x length of side, which is 6 power 2, times cotangent pi, which is 180 over 8. Equals 72 times 1/10, 22.5 degree. The approximated value is 173.8 centimeters